Hello everyone, my name is Vardan Papyan and my topic for today is convolutional dictionary learning via local processing. This is a joint work with Yaniv Romano, Jeremias, Sulam, and Professor Elad. So convolutional sparse coding is a global model for images that assumes that an image is a summation of different local filters convolved with sparse feature maps. You can write it in a matrix form by saying that the global image X, vectorized, is a multiplication of structured dictionary times a global sparse representation, where the dictionary contains in its columns the different filters shifted in the different places, and the representation is obtained by interlacing the sparse feature maps. In what follows, I denote the unique set of filters at a certain position by DL, local dictionary. In a previous work, we showed that you can analyze theoretically this model, and you can prove that there exists a unique global representation that is locally sparse, that algorithms manage to find it, and that they remain stable even when you add noise to the signal. And the bottom line was to show that this model is global, but its theory relies on local properties. In this work, we focus on the practical aspects of convolutional sparse coding. And most of the current works tackle this problem by relying on ADMM solvers in the Fourier domain. But in our work, we claim that there are several disadvantages to doing that. For instance, most of these works do not really work well, do not scale to large images, large data sets, or to many channels. They're not easy to implement, usually hard to understand what they're doing in every step. They cannot leverage tools developed over the years in sparsity. And beyond all, CSC is a global model whose theory relies on local properties, which means that you should be able to solve the global sparse coding problem using local operations. So to do this, we introduced the notion of a slice. And we define the slice I as I to be the multiplication of DL times alpha I, such that you can write the global signal X as aggregation of different slices in different positions. Then we put this in the convolutional sparse coding problem and obtain an equivalent formulation for which you can write the augmented Lagrangian and optimize using ADMM. And then you obtain the following algorithm, which is called Slicebased convolutional dictionary learning, which begins by solving a local pursuit on different slices. Then it estimates the slice by multiplying the obtained sparse vector by the local dictionary. It aggregates the different slices using something like patch averaging, computes a local Laplacian, which is perhaps the most interesting operation, updates the dual variable, and updates the dictionary, and loops over all of this. If you would like to hear more about this algorithm, or the applications it leads to, or the relation to CNN, come to poster number 13. Thank you.